Hello! In this video, I'm going to show you how to calculate a backpropagation neural network. So here, in this example, you can see how the neural network looks, and there are 5 main steps to calculate a backpropagation neural network. First, calculate the weighted sum. Second, apply the activation function. Third, calculate the error. Fourth, update the weights. So as I said, the first step is calculate the weighted sum. So let's start. As you can see in this neural network, we have 2 layers. In the first layer, there is a linear activation function, and in the second layer, we have a tanh activation function. I have already wrote down the derivatives of it. The first activation function derivative is 1. The second activation function derivative is 1 minus tanh squared. Eta is our learning rate and D is our desired outputs. We have weights for every connection and additional weights for every neuron. Firstly, as I said, we want to calculate the weighted sum. So we will calculate the weighted sum, which is V. 1 to 1 is for the first neuron. V2 of first layer is for second neuron. V3 for first layer is for third neuron. V1 for second layer is for this neuron. V2 for second layer is for our last neuron. So first, let's calculate the first layer neurons. So the neuron is calculated by our input, which is multiplied by weight plus another input multiplied by its weight. Because this neuron is connected through these weights, this and this, to these inputs. I can show you, for example, like this. And this is for the first weighted sum. And of course, we add the additional weight of B. So as I said, we calculated by our input x1 multiplied by weight 1, 1 of first layer. It is 1, 1, this one, first layer. Then we add a x2, which is our another input, multiplied by weight. Yes, you guessed it, V1, 2 of first layer. 1, 2 of first layer, and then we add the B1 of first layer. B1 of first layer. So similarly is for these 2 neurons also. So we do x1 is multiplied by W2, 1 of first layer plus x2 multiplied by W2, 2 of first layer and added a B2 of first layer. So here we can see x1 is multiplied by 2, 1, and x2 is multiplied by W2, 2. So the first weighted sum is x1 multiplied by W3, 1 of first layer plus x2 multiplied by W3, 2 2 of first layer plus B3 of first layer. After this, we need to calculate the weighted sum of these two neurons. However, we cannot yet because we first need to apply the activation function to already gained weighted sums. So do for activation. Activation we will write as y1 of first layer. So this is for the first neuron. Y2 for first layer and Y3 for first layer. And again, I will mark it down which part it is. So this is the activation, and we can see this is the activation here. So activation for our first layer is linear. We can see it here. So we can just write that y1 of first layer is equal v1 of first layer, and similar to others, which is y2 of first layer is v2 of first layer, then y3 of first layer is v3 of first layer. Now that we have our activation functions for first layer, we need to use our activation functions for the second layer, but we cannot get them until we get the weighted sum of second layer. And now that we have the activation functions administered to the first layer, we can write the weighted sum of the second layer, which is our output of the first layer multiplied by the weights. So V1 of the second layer, is the sum of y1, y2, and y3 of first layer, which are multiplied by weights of the connections, like this. So we can write it down. Wait. Okay. We can write it down like this. Y1 of first layer is multiplied by W11 of second layer, added Y2 of the first layer, which is here, multiplied by W12 of second layer, W12 of second layer. Here we can see it 1 1 1 2 1 3, and added y3 of first layer multiplied by w13 of second layer. And here let's not forget to add the b weight, so b1 of second layer. Okay, and the same is for our other neuron. So we get y1 1 multiplied by w21 w of the second layer, added a y2 of the first layer, multiplied by w22 of the second layer, added y3 of the first layer, multiplied by w23 of the second layer, and added a b2 of the second layer. So we have our all weighted sum. I shall mark it down. So this is our weighted sum. Now, let's do the activation functions for the second layer neurons. So here, the second layer neurons activation would look like this. Y1 of the second layer and Y2 of the second layer. So Y1 of the second layer will mark down by this, like this. And we already know that our second layer activation function is tan h from the weighted sum. And so we write a simpler form than this, tan h from the weighted sum of second layer neuron. So V1 of the second layer, and the same, well, almost the same for the second neuron. We do the tan h V2 of the second layer. And we have all of our activation. We have the activation of first layer neurons, and we have the activation of the second layer neurons. I will mark it down as this. The third step is calculating the error. So error calculation is pretty simple. In error calculation, we just subtract the second layer neuron output from our desired outputs. So error 1 is equal to desired output from which we subtract the second layer first neuron output, Y1 of the second layer. And for error 2, which is the error of the second output, we subtract from desired outputs our second neuron output, Y2, 2. Well, we could see that this Y1 of the second layer and Y2 of the second layer are equal to Y1 and Y2. So this is how we calculate the error. I think it's pretty simple, the error calculation. Okay, so our last step is updating the weights. And this step is, we could say, the hardest one. So for updating, we first need to get the update margins for all of our neurons, for the first layer neurons and for the second layer neurons. And since this is backpropagation, we calculated backwardly. So firstly, let's calculate our second layer neurons margin. So we will call it our delta out 1 and delta out 2. So delta out 1 and delta out 2. And it's quite simple. To calculate our delta out of our second layer, we have to multiply our error of that output and the derivative of activation function for that neuron. Error 1 is multiplied by activation function of the second layer derivative for that neuron. We have to write it down for every neuron, so that would be E1, error 1, is multiplied by 1 minus tan h. This tan h is the activation of our second layer. So tan h of V1 of the second layer squared. This is how we calculate. Of course, we can write it in a simpler form because we can see this tan h of V1 of the second layer is exactly this activation part. So we could write it down as a y1 of the second layer. So let's write it down. So error 1 is multiplied by 1 minus y1 of the second layer squared. So yeah, we can write it down like this. So similarly, we write it for our delta out 2 for the second neuron. So we write it error 2 is multiplied by phi 2 derivative, which is E1, and I'll just skip this part and write, oh, not E1, E2. I'll just skip this part and write multiplied by 1 minus y second of the second layer, which is squared. So okay, so we have our margins, our deltas, so we could update our weights for the second layer. So now let's get the deltas so we could update our first layers. So it will be delta 1, delta 2, and delta 3. To calculate these 3 deltas, we have to multiply our first layer activation function derivative, so phi 1 derivative, which is 1. We calculate it by each weight, like each weight that comes back from our second layer. So let's take to example the first neuron. So I will draw it by green. So we have these 2 weights, and we have to get the sum. So we get these 2 weights, not weights, connections, which are multiplied by the corresponding delta out 1 and delta out 2, which is delta out 2 from the second neuron and delta out 1 is from first neuron of the second layer. So to calculate the delta 1, which is for the first neuron of the first layer, as I said, we have to multiply phi 1, which is again equal to 1. So there's not a lot of writing about that, but we multiply it by corresponding delta out 1 from the first neuron of the second layer. So delta out 1 is multiplied by the corresponding weight, so W11 of the second layer, and it is sum of the delta out 2, which is the second neuron from the second layer, delta out 2, and multiplied by the corresponding weight. So W21 of the second layer And yeah, that's it. That's how you calculate the deltas for our first layer. So again, let's calculate the other deltas. So remember, this is equal to 1. So we don't need to write it into another form because we know, well, I'll just write it down. This is equal to delta out 1 multiplied by W1 1 of the second layer plus delta out 2 multiplied by W2 1 of the second layer. So let's calculate the delta 2 and delta 3. So phi 1 derivative is multiplied by delta out 1. For the second neuron of the first layer, it is W12 and W22. So W12, the second layer, plus delta out 2 multiplied by W22 of the second layer. And delta 3 is phi 1 derivative multiplied by delta out 1, which is for the third neuron of the first layer, it is W13 of the second layer plus delta out 2 multiplied by W23 of the second layer. So now that we have all of our deltas, we can finally update our weights. So let's do exactly that. So we'll update the first weight of the first layer. So this one. So to update that weight, we need to take that weight and add learning rate multiplied by the delta for that neuron. So this is the first neuron, so we take the first delta, so multiplied by that delta and multiplied by that input which the weight is connected to, so x1 in this case. And this is how the weight is updated. So let's take the second weight for the first neuron of the first layer. So W12, we can see this is the W12. I'll just mark it down so it would be easier to get which one it is. It is this one. We calculated similarly like the last one. So we take W1, 1, 2 of the first layer and add learning rate multiplied by delta of that neuron. So this is still for the first neuron, so delta 1, and the input which it's connected to with that weight. So in this case it's x2. And this is how we updated the weights for the first neuron. Let's now update the weights for the second and third neurons. W21 for the first layer and W22 2, 2 for the first layer. Again, we take that weight to one of the first layer and add a learning rate multiplied by the neuron it is connected to. So this is delta 2, and from which input it is. So x1. And the second weight for the second neuron of the first layer. I know that sounded intense. First layer, second weight, we add a learning rate multiplied by delta of that neuron and multiplied by the corresponding input. And we do the same for the third neuron of the first layer. We take that weight, this free one of the first layer, and we add a learning rate multiplied by corresponding delta of the neuron and by the connecting input x1. Oh, this is not delta 1, this is delta 3. Made a mistake. And w3 2 of the first layer, add learning rate multiplied by delta 3 multiplied by x2. We have all the weights for the first layer. Actually, no, we haven't, because we need still to update the B weights. And updating the B weights is a bit simpler, because we need to take that weight and we just add a learning rate multiplied by delta for that neuron. So B1 of the first layer, B2 of the first layer, and B3 of the first layer. And we calculate by taking the same weight. We add a learning rate multiplied by the corresponding delta of that neuron. So since this is the first neuron and B1, we take the delta of the first neuron. And we do the same for the B2 of the first layer. We add a learning rate multiplied by the corresponding delta of that neuron. And for the third weight, we add learning rate multiplied by delta of third neuron. So now we have updated all the weights for our first layer. It's time to update the weights for the second layer. And the logic is the same. We take the weight and we add the learning rate multiplied by the corresponding input of that connection for that weight and multiplied by delta of the corresponding neuron which it goes through. So like for the W11 of the second layer, we take the, let me just mark it down, it's green, so green here, this is this. We just take that weight and we add a learning rate multiplied by delta of that neuron. So for the first neuron of the second layer, it is delta out 1. We multiply it by delta out 1 and the corresponding input of that weight. So for W11 of the second layer, the corresponding input would be from the first neuron of the first layer, and it is a Y1 of the first layer. Y1 of the first layer, it is this one. So So multiply by y1 of the first layer. And this is how it's done. Let's now do for the second weight. So the second weight goes from here. So W1, 2 for the second layer, and W1, 3 for the second layer. Those are the weights that come into first neuron of the second layer. Let's just calculate them. So 1, 2 of the second layer would be, we add a learning rate, which is multiplied by the corresponding delta of that neuron. So since this is the first neuron of the second layer, still do delta out 1, and we multiply it by the corresponding input. So this from the second neuron, so it would be y2 of the first layer. And we do the same for the third weight, so W1, 3 of the second layer. We add learning rate multiplied by delta out 1 multiplied by y3 of the first layer, because this is the weight from the third neuron of the first layer. And let's not forget to update the b weights of the second layer. So let's just write it here, b1 of the second layer. And again, for b, we just take the same weight, b1 of the second layer, and we add a learning rate multiplied by delta of that neuron. So it would be learning rate multiplied by delta out 1. Okay, let's do the same for the second neuron of the second layer. So W2, 1, W2, 2 of the second layer, W2, 3 of the second layer. And let's write them. W2, 1 of the second layer plus learning rate multiplied by delta out 2, because it's for the second neuron, and multiplied by y1 of the first layer. Whoop, this is like that, because this 2, 1 is from the first neuron. So 2, 2 of the second layer, we add learning rate multiplied by delta out of the second neuron of the second layer, and multiplied by y2 of the first layer, because this weight is connected to the second neuron. And y2, 3 of the second layer, we add a learning rate multiplied by delta out 2, and multiplied by y3 of the first layer. And we do the same for the b2 of the second layer. So b2 of the second layer would be b2 of the second layer added learning rate multiplied by delta out 2, because it's for the second layer. So now we have updated everything, we have done everything. So to finish this up, we need to do one last step. It is the 5th step, and it is important, but it is very simple, because we need to repeat all of those steps from the 1st to 4th step. 4th step, this is included, the updating all the weights. We need to repeat those steps until the error is equal 0, or as close as it is possible to 0. So this is very important, until the error is 0. So this is the fifth and last step. So okay, and this is done. We have calculated our neural network. So thank you for watching, and I hope I'll see you in the next video. Bye bye! So as I said, I will thank each and every one of my patrons. So thank you, Aditya Vamsi Pulipakam. I'm sorry if I spelled it wrong. You're my first patron, and you helped me to create this content.